So hello guys, welcome back to our channel C for Carbon. Today our objective is to find out what is the minimum number of carbon atoms required to show optical activity in alkane, alkene and alkynes. So the basic requirement for having optical activity is the need of a chiral carbon, as you all know. Chiral carbon means a carbon atom attached with four different substituents. For example, like A, B, C, and T. Okay. So, if it is an alkane, how many carbon atoms means which the alkane with the minimum number of carbon atoms that can show optical activity. That is what we want to find out. So, let us take, for example, we have a carbon. Okay, so the first group that we can put is hydrogen. Okay, then the next alkyl group which we can put with the minimum number of carbon atom is methyl group, that is CH3. So the next group with the minimum number of carbon atoms will be CH2 CH3, right? We cannot put again CH3 because it will become break the rule of chirality won't be achieved if we put again CH3. Now our next bet is on CH2 CH2 CH3, the propyl group, CH2 CH2 CH3. Okay, so here you can see in this carbon atom four different groups are attached, right? H, CH3, CH2, CH3 and CH2, CH2, CH3, right? So this is chiral, right? This is chiral. So how many carbon atoms are there total? 1, 2, 3, 4 plus 3, 7. So for an alkane there should be minimum 7 carbon atoms to show optical activity. So now we are moving on to alkene, the case of alkene. So I will draw a line here to separate these three hydrocarbons. So for alkene, we follow the same procedure. We take carbon. Now first we can put hydrogen. Then we can put, of course, what? CH3. After that we can put CH2 CH3. Okay, next we cannot put this what? CH2 CH2 CH3, that is propyl group, because if we put that propyl group, what happens? This is not an alkene, that becomes an alkane. So we have to put an alkenyl group with the minimum number of carbon atoms, and our best bet is CH double bond CH2. Okay, now if you look at this carbon atom, this is chiral. Why? Four different groups are attached: H, CH3, CH2, CH3 and CH double bond CH2. Okay, so how many carbon atoms are there? One less than the previous one, right? 1, 2, 3, 4, 5, 6. So 6 carbon atoms are required in an alkene. The minimum number of carbon atoms required in an alkene to show optical activity is 6. Now moving on to alkyne, we follow the same procedure. Carbon, hydrogen first we will put, then of course the methyl group CH3. After that CH2 CH3 itself, that is ethyl group. Now we cannot put, 1 minute, I will just make an adjustment here. Sorry, again my mistake. Okay, so CH2 CH3. Okay, now we have to put, we cannot put the previous CH double bond CH2, right? That Why? We will make it an alkene. We want an alkyne. So our best bet is on C triple bond CH. If we put C triple bond CH, this whole molecule becomes an alkene, and this carbon atom in the middle will contain four different groups, right? H, CH3, CH2 double bond, sorry, CH2, CH3, and C triple bond CH. So the minimum number of carbon atoms required here is what? How much? If you add, it will be 6 only, right? If you count, it will be 6 only. So 6. Okay. So hope you understand what I have told today. If you like the video, share the video and subscribe to the channel. Thank you.